All right, welcome everybody. Today we're going to talk about the second day of section 9.1, and today we are going to be solving with SOHCAHTOA. When you are solving with SOHCAHTOA, you actually are allowed to have decimals, and we're going to ask you to round all your answers to 2 decimal places. First, a quick review of the 6 trig functions. You'll see here we have the sine, the cosine, and the tangent. Remember SOHCAHTOA for short. And then we have the 3 reciprocals, the cosecant, the secant, and the cotangent. These are in relation to the right triangle that you see over in the right-hand box. Remember that the right triangle, you would be told that it's a right triangle by either giving you the 90 degrees or by giving you the corner mark. And then again, remember from your geometry days, if you are naming a triangle, you need 3 vertices, and those are going to be the angle measurements. So whenever you see an uppercase letter in relation to triangles, that is going to denote an angle. So you would say angle capital A or angle capital C. Then remember that side lengths are denoted with lowercase letters, and they're directly across from the corresponding angle. So side A is across from angle A, side C is across from angle C, and then side B is across from angle B. So something to keep in mind as we proceed through today's lesson. Notice that for the problems in question here, they're talking about the sine, the cosine, and the tangent of A, which means they are looking here at angle A. Once you decide you're looking at angle A, this would of course be the opposite, the adjacent, and the hypotenuse. So remember, those 3 sides are going to change depending on the problem. So take a look at what it's asking you to do here in the first set. You're going to set up an equation for each triangle using SOHCAHTOA and then solve for the missing side. We're going to ask you to round all your answers to 2 decimal places. Now, when we say that you're going to use SOHCAHTOA, technically you could use the other 3, the secant, the cosecant, and the cotangent, but it's just much easier if you use the sine, the cosine, and the tangent, and it's especially easier from a calculator perspective. So that's why we're going to go ahead and focus on those. So notice here in these problems, in all the cases you are missing a side length, but notice in all the cases you have right triangles, which means SOHCAHTOA is going to get the job done. So here in number 1, you are given the missing side length x, you are given the angle 24, and you are given the side of 12. What you need to do is decide what trig function, sine, cosine, or tangent connects those 3 values. You might want to label them at first, and then you'll get better at them the more that you do. Given the angle 24, the x would be the opposite and the 12 would be the adjacent. Once you realize that, you know that this is a tangent problem. So you're going to say the tangent of the angle 24 is equal to the opposite value over the adjacent. Now again, this is different than what we did yesterday, because yesterday we never knew the angle. Instead, we always knew just the sides. So you are inserting different values, but you're still using the same ratios. This is technically the tangent of 24 over 1, which means if you're trying to solve for x, you're going to simply cross multiply. So you're going to get that x is equal to 12 times the tangent of 24 degrees. Now you are going to want to actually find that value, and in order to do so, you're going to need your calculator. So a couple of things to make sure that your calculators are in the right setup. So first, I'm going to show you how to do it on the graphing calculator. The first thing you have to do once today, and you shouldn't have to do it ever again for the next couple of days as long as you do it now, once you turn it on, you're going to press the mode key. The mode key is top leftish here next to the second button. You're going to press mode. You're going to go down to where you see radian versus degrees. We're going to talk more about radians later in the chapter, but for now, you're going to make sure that the degree mode is highlighted. So you have to do whatever you need to do, scroll your arrows, hit enter, make sure that the degree is highlighted, or else all of your answers are going to unfortunately be incorrect. So once you've gone ahead and highlighted degree, you can go ahead and second mode, which quits, bring you back to the home screen. So we said that you're going to calculate by doing 12 times the tangent of 24. Notice here in the middle of the calculator, you see your sine, your cosine, and your tangent. So you're going to go ahead and plug in 12 times the tangent of 24. Notice it opens a parentheses for you, so you're going to go ahead and make sure that you close it. Whatever answer you get here, you're going to go ahead and round to exactly 2 decimal places, and you're going to add that to your sheet. So the answer here is 5.34. So x is equal to 5.34. And again, you do have to make sure that you calculate that decimal. You're going to go ahead and do it to exactly 2 decimal places. Let's go ahead and take a look at number 2. So in number 2, you have 51, you have 14, and you have x. Again, depending on whatever the angle is, you then have to decide, are the values in question the opposite, the adjacent, or the hypotenuse? So compared to the 51, this 14 is the opposite, where the x is the hypotenuse. So an opposite and a hypotenuse, that is, of course, a sine. So the sine of 51 is equal to the opposite 14 over the hypotenuse x. Notice here that instead of having the variable in the top, you have the variable in the bottom. It's going to work a similar way with one additional step. You're again going to cross multiply. And when you cross multiply, you're going to get x times the sine of 51 is equal to 14. In order to get the x by itself, you would have to go ahead now and divide. So you're going to have to do 14 divided by the sine of 51. In order to do that, if we go back to our graphing calculators, you're now going to do 14 divided by the sine of 51. And again, make sure you're using the division key. Make sure you close your parentheses. You're going to take that answer, round it to 2 decimal places, which would be 18.01. So again, the better you get at these, maybe you don't have to write the opposite, the hypotenuse, and the adjacent, but certainly it's always an option if it's helpful. Take a look here at number 3. Again, you're trying to connect this angle, this x, and this 6. Maybe you're getting a little bit more savvy, maybe not, but compared to the 73, this is the adjacent and the hypotenuse, which means this is a cosine situation. The cosine of 73 is equal to x over 6. You're going to go ahead and again cross multiply, which tells us that 6 times the cosine of 73 is equal to x. Now to show you in Desmos how that's going to work. So if you take a look at Desmos here, okay, and you click the graphing calculator, you might have to reset this every time you go to Desmos. So here, you're going to start by clicking the little wrench in the top right-hand corner. Notice at the bottom, you see radians and you see degrees. You have to make sure that you're in degree mode. You don't actually know what radians are yet. So once you click degrees, then you're good to go. When you're just doing sine, cosine, and tangent, you can just type in the words. So if you're trying to do 6 times the cosine of 73, you can do 6. You can type cos. You can type 73, and it will, in fact, give you the right answer just by typing sine, cos, or tan. You see your answer there. You're going to round it to 2 decimal places, so that is going to be 1.75. Okay, so not only is it important that you're able to set up the correct ratio, but it is important to make sure you can also calculate it. So then take a look at these next 2 triangles. Notice that they're just ever so slightly rotated, which is important to make sure that you can identify sides and angles no matter what the rotation. So in a case like this, if you're looking at the 55, you're looking at the opposite and you're looking at the adjacent. So continue to label them as needed. Otherwise, if you can kind of skip a step, by all means, the tangent of 55 is equal to the opposite 29 over the adjacent x. And again, this is the opposite and the adjacent. You would have to cross multiply. So x tangent of 55 equals 29. Then you would have to divide, so 29 over the tangent of 55. Now that I've shown you how to do the calculations, you should be confirming them as I do them, but you should in fact get an answer of 20.31. And last but not least, again, based on where the angle is, if you're talking about the 21, you're talking about the opposite, and you're talking about the hypotenuse. That is a sine of 21 equals x over 22. You're going to go ahead and cross multiply. So 22 sine of 21. Whatever device you regularly use, you should go ahead and plug in 22 sine of 21, and you should confirm that you do get 7.88. If you're not able to get the correct answers now, you're not going to be able to get them when you do the homework. So you do want to confirm whatever device you're using that it works. Then the opposite of solving for a missing side is continuing to use SOHCAHTOA, but solving for a missing angle. If you're going to solve for a missing angle, you're still going to be using sine, cosine, and tangent, but now you also have to use something called the inverse functions. So again, I'm going to show you the setup, and then I'm going to show you how to do it both on the graphing calculator and on, Desmos. So notice in each of these three cases to start, there's no triangles, there's just angles. So you have sine, cosine, and tangent. You're trying to find the missing angle x. If you have a sine and you want to solve for the missing angle x, you have to get rid of the sine. The way that you get rid of a sine is by taking something called an inverse sine. If you remember back from our discussions throughout the year, the way that you say inverse is a little -1 exponent, which means if you want to solve for x, you're going to take the inverse sine of 1/3. Here in the middle, if you want to get rid of the cosine, you're going to take the inverse cosine of both sides. Here on the right, if you want to get rid of a tangent, you're going to do the inverse tangent of both sides. So now that you've written it as an inverse, now you just have to plug it into the calculator. And again, I'm going to show you how to do it in both devices. So if I go back first to the graphing calculator, if I want to do the inverse sine of 1/3, notice that on top of your sine key in blue, you see a little sign with a -1. That is your inverse sine. Then you see your inverse cosine and your inverse tangent. In order to bring up that inverse, you have to press the second key. So I'm going to press the second key and then sine, and notice that that brings me up the inverse sine. Now you're going to type in 1 divided by 3, which is 1/3. Close parentheses. Whenever you do that, whatever comes out of your calculator is an angle. So you have to add degrees. So 19.47, that is going to be your answer for x. And you're going to, of course, write it with degrees. So 19.47 degrees. In the middle, you're doing the inverse cosine of 8/9. So again, back to the graphing calculator. If you want to bring up the inverse cosine, you're going to do second cosine. You're doing it of 8 divided by 9. Close parentheses. That is an angle, which you're going to round to 2 decimal places. So 27.27. So x equals, 27.27 degrees. And again, you should remember to put in your degrees. And now we're going to have to go ahead and do the inverse tangent. And I'm going to show you how to do this one on Desmos. So if you pull up your Desmos, you should still be in degree mode as long as you haven't left the screen. But again, if you did leave the screen, you're going to have to do it again. So first, clear out my old calculation. You're going to have to press the little toolbar. Then you're going to have to choose functions. Then notice this is called the trig menu. So see how you have not only your sine, cosine, tangent, which you can continue to click those buttons or just type the abbreviation. And then in the middle here, you have all your inverses. There's no way to type the inverse in other than to click it here. So here you're doing an inverse tangent. You're doing it of 7/5, so 7 divided by 5. Notice it's going to give you the angle measurement right here, which you're going to round to 2 decimal places, which is 54.46 degrees. So x equals 54.46 degrees. So again, as I go through these problems, you should be confirming with whatever device you plan on using for the remainder of the chapter to make sure that you can, in fact, get those correct answers. So taking a look here at the next set, notice that it has a question mark. I would recommend that you assign it some variable. Let's just call it angle x. Compared to angle x, this is going to be your opposite and your hypotenuse. So this is going to be the sine of the missing angle x is equal to the opposite 51 over the hypotenuse 55. In order to solve for x, you have to get rid of the sine, which you do by taking the inverse sine of 51 over 55. Again, I already did these on my own, so you should take whatever device you plan on using. You should go ahead and make sure that you can calculate 68.01, and again, that's a degree measurement. Here in number 2, again, it's just a question mark, so I would recommend calling it an x or a theta or something else because the question mark is a little strange. Compared to the question mark, this is the opposite and the adjacent, so that is the tangent of the angle equals 8 over 20. In order to get the angle by itself, you're going to have to go ahead and do the inverse tangent of 8 over 20. And again, I've already done it. You're going to confirm it on your own device, which is 21.80 degrees. So I think this would be a good place for you to pause and try it. So why don't you go ahead and try and see if you can do 3, 4, and 5. See if you can correctly choose sine, cosine, or tangent. See if you can do the correct inverse using whatever your device is. And then we'll go over those answers together. All right, so if you tried 3, 4, and 5, here are the answers. Number 3, you should have used cosine. Then by finding the inverse, 21.79 degrees. Cosine for number 4, 61.93 degrees. And sine for number 5, 70.81 degrees. If you have any questions or had any issues with 3, 4, and 5, please make sure to ask your teacher. Then after you have mastered solving for a single side or a single angle, you might be asked to solve a right triangle. So whenever you see the word solve, it means you have to find all the missing sides and all the missing angles. So really not harder than anything we've done so far, just a little bit longer. In order to do so, you're going to use the fact that all the angles in a triangle have to add up to be 180 and SOHCAHTOA. So take a look here at the next problem. You are being asked to solve the right triangle. If you're being asked to solve, it means all the sides and all the angles. Notice that this is triangle DOG. Over here on the left side, these capital D, capital O, and capital G, those are the angles, where the lowercase on the right is the side lengths. So as a reminder, the side lengths are directly across from the corresponding angles. So if this is angle D, then this would be side D. If this is angle O, then this would be side O. And if this is angle G, then this would be side G. So I'm going to go ahead and fill in the things I already know. So I already know that angle O is 90 degrees. I know that side O is 18, and I know that side G is 7. Now I have to find the other two missing angles and the missing side. In order to find the next value, all I can do right now is find the third side. So to find the third side, I'm going to go ahead and use the Pythagorean theorem. So I'm going to say that D squared plus 7 squared is equal to 18 squared. So D squared, if I do 18 squared minus 7 squared, that's going to be equal to 275. If I take the square root, remember you're going to take the positive version only. The biggest perfect square in 275 is 25, and it goes in there 11 times. So you can say that D is equal to 5 times the square root of 11. Now for these triangles, because we have been solving, technically you could make it a decimal, which would be 16.58. Again, because it said decimals were allowed today, either of those would be acceptable. You now have to find angle D or angle G. Doesn't matter which one you find, so it's kind of up to you. I'm going to go ahead and go for angle G. If I go for angle G, my advice would be to use the given values. What if, let's say, your D, your little d, was wrong? Then your next answer would be wrong because of it. So I'm going to go ahead and stick with the given values. So if I'm trying to find angle G, then I would have my opposite and I would have my hypotenuse, which means I'm going to go ahead and do the sine. So I'm going to be allowed to say that the sine of angle G is equal to 7 over 18. In order to find angle G, I would have to do the inverse sine of 7 over 18. If I plug that into my calculator, I'm going to go ahead and get that angle G is 22.89 degrees. For the last angle D, instead of setting up another SOHCAHTOA, all I have to do is remember that if I add up all 3 of these green angles, I have to get 180 degrees. I already know that O is 90, which means that if I know that G is 22.89, if I do 90 minus 22.89, that is going to give me the third angle, which in this case is 67.11 degrees. So again, when you see solve the right triangle, it means find all the missing sides and all the missing angles. When you're done, a quick way to check that you've done this correctly is the largest angle should always be across from the longest side. The smallest angle should always be across from the smallest side, and then the middle should always be across from the middle. So just a very easy way for you to check. We're going to finish up with some word problems, and before we do so, just a little bit of vocabulary. Sometimes the pictures are given to you in these word problems, and sometimes you have to draw them. If you see the word angle of elevation, please make sure that that means that you are looking up from the horizontal. If you see the words angle of depression, please make sure you know that that means you're looking down. So here they are on the left, floating out in space, and then here they are in the terms of a picture. All right, so our last two problems here, which are word problems, again, don't be scared off by the fact that they're word problems. It normally just means that your decimals are a little bit messier. So a surveyor is standing 115 feet from the base of the Washington Monument. That's here. The surveyor measures the angle of elevation. Remember, that means you're looking up to the top of the monument at 78.3 degrees. They want to know how tall is the Washington Monument, and they're calling that Y. If they use a variable, I suggest you use it as well. Or if you have to write your own, that's fine. I'm going to go ahead and just pop out the right triangle so I can see it a little bit more clearly. They're calling the height Y. They're calling 115 feet away. And then this angle here is 78.3 degrees. Using those three values, you want to choose a sine, a cosine, or a tangent to connect the three. Looking at the angle, I see the opposite and the adjacent. So this is a tangent situation. So the tangent of the angle, 78.3, is equal to the opposite y over the adjacent, which is 115. You're going to go ahead and simply cross multiply. So you're going to get that y, which is the height of the monument, is equal to 115 times the tangent of 78.3. Use whatever graphing utility you are used to, and you're going to go ahead and get an answer of 555.31 feet. Just FYI, if you were to actually Google how tall is the Washington Monument, you'll get various measurements because it is sinking slightly, but they'll all be slightly around 555 feet. And again, for word problems, you should go ahead and use a unit. Then for number 2 here, there is no picture, so you're going to have to go ahead and draw one. So a ladder has to reach the top of a building. The base of the ladder is 25 feet from the base of the building. The angle of elevation from the base of the ladder to the top is 64. Find the height of the building H and the length of the ladder M. So even though they don't give you a picture, they do give you some variables, which again, I strongly suggest you use. So here is my building. And then here is my ladder. Hopefully, if you've ever seen a ladder in action, a ladder leans. So that's why it is your diagonal. And they're telling you to call that M. They're telling you to call the height of the building H. You would hope that buildings are built perpendicular to the ground with a right angle, or else that would be a bit of a mess. The base of the ladder is 25 feet away, and the angle of elevation is 64 degrees. You have to solve for M and H, and you're going to go ahead and do them one at a time. Doesn't matter which one you choose to start, I'm going to solve for H. So I have to connect the given information to the H. To me, that looks like an opposite and an adjacent, so this is another tangent situation. So the tangent of 64 equals H over 25. If you go ahead and cross multiply 25 times the tangent of 64, you're going to go ahead and calculate 51.26 feet. That is, in fact, the height of the building. Now you need to find the length of the ladder. So to find the length of the ladder, you're going to use the original data plus the M. So now that you've added the M into the mix, that is the adjacent and the hypotenuse, which means this is a cosine situation. So you're going to say that the cosine of 64 is equal to 25 over M. When you cross multiply, you're going to get M times the cosine of 64 equals 25, which means you're going to have to divide. So 25 divided by the cosine of 64, and again, use your favorite graphing utility. That is going to tell you that 57.03 feet, in this case, is going to represent the length of the ladder, and hopefully that should make sense. Remember, in this case, the ladder is the length of the diagonal, which should always be the longest side of the triangle. So for your homework tonight, be sure to round to 2 decimal places and use your favorite graphing utility. Thanks very much for tuning in, guys, and we will catch you next time.